Let's now talk a little bit about what to do after model evaluation. As we mentioned before, the evaluation is quantifying how models are performing, and after having such quantifications, typically in the form of scores, we would be able to make a judgment about the performance of a model. So in light of some model or models that are not performing as intended, we would need to recalibrate, and that's the idea of tuning the models. And basically, there are three scenarios here. A scenario in which that is called underfitting. There is another scenario that's called overfitting, and another one that is considered appropriate fitting. So this idea of fitting is because we are using observations, measurements, data points, and we are using this machinery of models. What's illustrated here in the screen is a very general illustration of a scenario with two classes or two categories. The boundary, here the categories are, the data points are, the shapes are either circles or stars. So each shape is representing one class or one category, and the boundary is a very simple boundary here, illustrated by a line. It's another version of what we were discussing before with circles and squares. So the output would be this so-called boundary or frontier, and to one side of that boundary the data points are classified as class 1, to the other side they are classified as class 2. And so let's make some observations or comments here. So after examining quantifications of model performance, we may conclude that the model perhaps did not perform as expected, in part because it was not capturing important, meaningful patterns in the subset of the data used for in the stage of model training models. A very important thing to remember is that the models are the data is an input of the model, and this subset of data, there is one that's called training. So what we assess out of the training data set is going to be very important as to how we want to establish if this model can make generalizations. So a model that is underfitting is one that is not performing well with this subset that we call the training data subset. And if it's not performing in that subset, it's not expected to perform well with the complete set of the data, or is not expected to perform better in scenarios where there are more general patterns reflecting general features to whatever the data is representing. So what so basically the reflection here is that perhaps the model is way it's overly simplistic, and that is basically incapable of handling important patterns of the training data set, but ultimately of whatever the training data set is always a sample, is always reflecting, is like, yeah, I think sample is the right word, is a sample of a much larger, of more larger patterns, right? So if at this level with this sample the model is really incapable of capturing these important patterns, then we expect this poor performance on other subsets of data that presumably would have generalizations of the patterns. So one way of addressing this is by using these so-called hyperparameters, and making calibrations, recalibrations, or adjustments of the so-called hyperparameters. It is possible that this is a red flag that makes us go back to the pre-processing of data, right? So this is a previous step on the life cycle of machine learning. This is where we may need to perhaps do additional processing steps. Remember, part of what's involved sometimes in these steps is dealing with missing values. There may be columns or features that may need to be transformations. This is so the whole idea of feature engineering, constructing new features, maybe using scaling factors, transformations of that nature. So there may be something we need to revisit in previous stages or previous steps of the machine learning lifecycle in order to address this underfitting situation.